Hey guys, it's Dr. Tracy here, and here's another video for Cisiweb 74, creating dynamic web content using JavaScript. This week we are doing object-oriented JavaScript. And if you click to look at the pages, you'll see the resources that are provided. You know, one thing I'll note is you do notice I use a lot of w3schools.com. This is my favorite resource on the web for some of the languages like HTML and JavaScript. So take a look at some of the other things that are on there in addition to the links that I give you, because that's always pretty good. PowerPoint this week. Our topic is object-oriented programming, and our topic this week has PowerPoint. Let me just go through that quickly. The basic idea of object-oriented JavaScript has already been something you used. It'll sound familiar even, because we used the document object model, and we considered the browser an object. An object is a collection of data sources, of functions and methods that you can use and access in your programming with JavaScript on a web page. But those aren't the only objects. And as this chapter explains, you can describe what objects are. You can use additional objects such as date, number, and math. And you can even create your own objects that have collections of methods and properties that can be adjustable in programming. The idea of object-oriented programming allows you to reuse code without having to copy it or recreate it. Now, this kind of transformed the way that programming languages were done, because prior to having object-oriented languages, codes were built on single machines and could not be transferred from machine to machine. Earlier machines did flat file programming, which was list numbers, line 1, line 2, line 3. If line 3 is this, then go back to line 1. And the reason why it couldn't be kind of copied and pasted was because the line numbers might be different on a different machine or a different program. So portability was not a good issue. Now we don't have line numbers. I mean, other than in our editing tools, but we do have objects. And objects can be imported and called, and their methods and data can be used and manipulated. So by reusing these software objects, we can incorporate them into multiple programs. Like you saw, for example, the browser object. That becomes very useful in multiple programs while accessing the same variables and functions. You can also create them as individual units or components, which helps for sharing the efforts when building larger programs and a higher scale, and also that you can keep your data protected within its own structure. Objects can be many different things. Simple controls with a few bits of data to the entire document with every single HTML tag that it contains. And many languages are object-oriented programming languages. If you look at this list, it says popular object-oriented programming languages: C++, Java, Visual Basic. JavaScript is not an object-oriented programming language. It is an object-based scripting language, which means it can function as an object-oriented language, but it does not run from its own engine, and it is not compiled. It runs through the use of a different engine. When you create, that's a discussion question this week, by the way, I think. When you create objects, you're able to reuse them. You can create your own objects and import objects created by programmers, like date and time objects. Encapsulation is one of the key tenets of object-oriented languages. And that just means that the data itself is protected in something like a black box, and it sets up an interface using programmatic methods that allow you to access, modify the data elements rather than changing them directly. So in this principle of information hiding, these methods have statements that are included within the object's creation that are not visible to any place outside of that object's programming. The advantages of encapsulation is that it prevents your data, as I said, and it reduces code complexity in the programs that are calling it. Because rather than having 25 statements about how to come up with this sum of numbers or whatever, a total. Instead, all you see is the function name, which tells you what it does. And if you name your functions or methods appropriately, then it'll read more like English. So in the example that's shown in figure 7-2, a programming object and its interface would be like compared to a handheld calculator. You don't need to know how the multiplication is done and the memory and all of that, but the object itself is just accessed through the nice little buttons and pictures that tell you how to find the answers. The document object that we've already used is encapsulated, and we have a function called getElementById, which you used in a previous chapter, that lets you communicate with the document object and pull out bits of data within the document object itself. So classes, when you talk about objects, you can't talk about objects without talking about classes. Classes are groupings of codes, methods, attributes that are all put together in what's made up of a class. A class is not an object. A class is the blueprint. It is the description of the object and all of the functions and variables that are contained as part of that object. Whenever you use a class, you call in a class in order to create an object. That's why I called it the blueprint. And when you create an object, you are creating an instance, or you are instantiating that object. When you create the instance of an object, it inherits all of the methods and properties that were defined within the class. So any variable that's put into the class as a data member and any method that was written as part of the class will now be as part of the new object that's created. You can make as many objects as you want from a class. It could be reused. I always use an analogy, like if you were in construction. That blueprint analogy works pretty well for me, because if you think about a blueprint is a design for a house. It's a thorough and complete design for how to build a house and what should be contained in it and how and why. Now, if you had a blueprint, you could make 400 houses and they'd all be exactly the same. And they would all have indoor plumbing and electricity and the plugs in the right places and so forth. Those houses would be objects or instances of the class. The class itself would be the blueprint. It's not an object in that sense, but it does give the definition on how the objects are created. There are several built-in JavaScript classes, and that means that these are portable objects that were created by other programmers that contain things that you may need to use. We're going to get into some array and string objects, I think, next week. But this week, we're talking about some of the code that is in math. For example, the math object contains things like how to use pi, how to calculate power. As you can see in this example down here, math.pi times math.pow. This dot in between the object name and what it's calling is the dot syntax that allows you to access the information within the class. The array, when we create an array, that's an object that instantiates an array in order to be filled. And a date object will bring back today's date in various things. Whenever you declare a variable or instantiate a new object, you are reserving memory for that. That means that you've held aside a block within your random access memory that's going to allow data members to be. Even if when you create the object, it's not instantiated with data members, just even if it has a null value, there's still going to be a memory that's reserved for it. JavaScript will know when to clean that up and will automatically clean up the memory when you're no longer using that variable. But garbage collection is a term in programming that means you can clean up or reclaim that memory by closing out that program early. The three objects that are used in this chapter are date, number, and math. Each one of those are existing JavaScript classes. Classes, again, being the blueprint on how to create them. Each class will have things like a memory and a constructor. Let's take a look at the date class in a little bit more detail. The date class, as is listed on this description, is based on the ECMA script for timestamps, date format, and timestamps conversion. It shows that within the date class itself, it has a constructor function. The function date, D-A-T-E, open and close parentheses, is a function that will create a new date object. And then it has properties that can be adjusted. So the properties of the date would be prototype, which allows you to add new properties if you need them, and length, which is 7, the number of arguments that are necessary. Methods include new or now to show the now, exactly what time it is in universal time, and parse if you wanted to return the number of milliseconds since 1st of January 1970. Date instances, when they're created, can create properties. Once you have the prototypes, you can get seconds, get minutes, get months, get hours. Once you have set up a date, and you can convert them to different examples of a string or to a different source. Here's an example of the way that date could be used in JavaScript. So if today is new date and we give it its information, we can enter it in multiple different ways. And then using that date, access its built-in methods like getTime. This shows you an example of the constructor functions and of the ways that you can create a date, either by providing arguments that'll help it be found, like, for example, the number of milliseconds since January 1st, 1970, kind of an arbitrary date, I don't know. When you manipulate the date and time class, we use the statement like var today equals new date. That means that I'm creating a new object that's instantiated from the date class. So var today equals new date is a new date object instantiated from the date class. When you create something that's a constructor function like this, that means that you have not populated the data members with any values, but you have reserved a place in memory for this new object that will have a year, a month, a day, and so forth. You could create a date object by using numeric representations like year and month and day. You can also, as I showed you in that example, have all of the 7 pieces that are part of the array of date. Once you've created the date object, then it is a static object and it will contain the data that it was populated with. It's not going to update over time like a clock. So once you've created it, maybe it's the date that someone became a member to a company or their birthday or whatever. Now we can use any of the date functions to pull out the day, full year, hours, milliseconds, month, second, minutes, time, or even the precise date right now, which you can create the date from. There's also methods that allow you to change the function of the date, and those are listed in table 7-3. Each portion of a date object can be retrieved and modified using these methods, so you could get those things individually. This is an example of the use of date. Today is today.getDay. Current day equals today.getDay. If current day is equal to 0, then weekday is Sunday. And so it returns you an array of what the value is of today. Here's another example of the use of it by pulling out the month. Okay, I'm going to stop there because I know lengthy videos get really boring to watch. But go through and take a look at the number class, which also is a brief a blueprint for creating or using numbers. And in the number class, it has several values and several functions that include a lot of math functions that are built in. You first have to use the math, include the math class, and you can access the math class with capital M math dot and then the function that's necessary. The defining custom JavaScript objects I'm going to come back with on a second video because it's kind of a different thing. I'd like you to play with classes first. So this is all for now, and I'll do more later.